Hello, Bobcats. Today we will be discussing stoichiometry. Okay, now, and stoichiometry involves the mole relationship between the reactants and products. So it's the mole relationship between reactants and products to determine the amounts of each substance in a reaction. So to determine the amounts of each substance in a reaction. Okay. So, stoichiometry problems are solved by using what we call mole-mole ratios. So the stoichiometry problems are solved by using mole ratios of compounds in a balanced chemical reaction, or of substances, because it could be an element also, of substances in a balanced, and it's very important, balanced, because it's the coefficients that we use. So in a balanced chemical reaction. Now, the mole ratios are determined from the coefficients of the balanced reaction. So the mole ratios are determined from the coefficients in a balanced reaction. So let's look at a general reaction. We're not going to use any specific compounds, we're just going to look at a general reaction. So if I have a general reaction like A2 plus 3B2 produces 2AB3. So what I'm saying here is that 1 mole of A2 will react with 3 moles of B2 to produce 2 moles of AB3. So my mole ratios in this would be, let's look at the mole ratios. We would have 1 mole of A2 for every 3 moles of B2. Or I can also have the reciprocal, 3 moles of B2 over 1 mole of A2. Or I can say 1 mole of A2 will produce 2 moles of AB3. So 1 mole of A2, substance A2, will produce 2 moles of AB3. So there's a 1 to 2 mole ratio there. And we can also have the reciprocal of that one. And then we have 3 moles of B2, so 3 moles of B2 when reacted will produce 2 moles of AB3. And so that's a 3 to 2 ratio. And then we also can include all the reciprocals. But I'm not going to write them all down. It gets too much. So you know what I mean. So I can have 2 moles of AB3 over 3 moles of B2. So let's say in this problem above, I want to determine how many grams of B2 are required to produce 100 grams of AB3. So I usually always write my information underneath the substance so that I know what I'm looking at. In this case, I know I'm looking at a 3:2 ratio. I don't have to worry about the A2 because that's not part of what I'm looking for. So I'm going to use one of these conversion factors, this one or either the reciprocal. So let's go through the problem and look how we would work that. So if I want to know how many grams of B2 are required to produce 100 grams of AB3, the first thing I would do is, I know I'm in mass, and the only way I can go from one substance to the other substance is through this mole to mole ratio. So I have to go from mass to moles. And of course, we've already discussed this. We know that anytime we're in an amount that's not a mole, we go to the mole. So I'm going to use molar mass. So 1 mole of AB3 will have some kind of mass. Now we don't know the mass because AB3 is a made up compound. So I'm not going to put a value here, but we know that that's molar mass. Now these units cancel, and so now I'm going to use, I got to go from AB3 to B2. So I'm going to look at this. I've got 2 moles of AB3 will need 3 moles of B2 to react. So I go for every 2 moles of AB3 that are produced, I have to react 3 moles of B2. So this is my mole to mole ratio. This is the stoichiometric step that takes me from one substance to the other substance. And I get that ratio from my coefficients up here. So now that cancels. I don't want moles of B2, I want grams. So I have to go one more step, and I'm going to use molar mass. So 1 mole of B2 is so many grams of B2. Now remember, we made this up, so I don't have a value to put here, but it's all about the units. And so I end up getting the mass of B2. So I'm using this stoichiometric ratio of 3:2 moles, but I'm using the reciprocal here because I had moles of AB3 on top. Now if I wanted to do the actual pathway for this, I would say we started out with a mass, so we have the mass of AB3, and anytime we have mass, we know we got to go to the mole, and so we're going to find the mole of AB3. And then when I have the moles of this substance, I can go to the moles of the other substance. So in this case, convert to the moles of B2 through the mole-mole ratio, and then I've got to go back to mass of B2 because that's what I'm looking for mass. So that means I have, every arrow has to have a conversion factor in this. So going from mass to mole, I'm going to use molar mass on this conversion factor step. And remember, we get the molar mass from the periodic table. Here we're going from moles of one substance to moles of a different substance. So we're going to use the mole ratio that we get from the coefficients of the balanced reaction. And then we're going from mole to mass. So again, we got to use molar mass as my other conversion factor. So there's my 3 conversion factors in that process. So now what we need to do is we need to practice. So we're going to practice 3 different types of stoichiometry problems, and a 4th one if we have time. So let's get started. The first stoichiometry problem that we're going to look at is, let's do number 1. So these are examples. So the first one is how many grams of ammonia gas can be produced from 10.0 grams of nitrogen gas. So we have to have a balanced chemical equation. So in this case, my equation is nitrogen gas, N2, plus 3 moles of hydrogen gas will produce 2 moles of ammonia gas. Now I'm going to write my information. I'm kind of running out of space. I didn't think I was going to need that much space, but I'm running out, but we'll do it anyway. It says how many grams of ammonia, so I want to know how many grams of ammonia will react with 10 grams of nitrogen. So again, we're looking at the 1:2 ratio. So I'm going to do my dimensional analysis. How many grams of ammonia when I start out with 10.0 grams of N2. Now the first step is, I know it's getting kind of crowded here, but the first step is I need to go from grams to moles using molar mass. So 1 mole of N2. Remember, this 10 grams is for the nitrogen up here. I should use a different color. Apologize. Is 28.02 grams for nitrogen. So 1 mole of nitrogen is that mass. Now I'm in nitrogen, so I've got to go from nitrogen to ammonia. So for every 1 mole of nitrogen, because there's a 1 here for the coefficient, for every 1 mole of nitrogen gas, I'm going to produce 2 moles of ammonia. Okay. Again, I got to go from grams to the mole, and then moles of nitrogen to moles of ammonia through the mole ratio, and then 1 mole of ammonia is 17.04 grams for 1 mole of ammonia. That's 14.01 for nitrogen, and then 3 times 1.01, which is 3.03. So 14.01 plus 3.03 is 17.04 grams. That cancels. I'm looking for grams of nitrogen. So in this problem, the answer should come out to be 12.2 grams of ammonia. And what I'm saying here is that when I react 10 grams of nitrogen, I should be able to produce 12.2 grams of ammonia. Now let's do a couple more examples. I won't be so crowded on the other ones. I'll make sure I have enough space. Well, take a minute to look at that. Make sure you get that down. I'm going to actually put these in different color just so you realize. So that's 10 grams for this, and then I'm looking for how many grams over here. So we can make sure we're seeing that. Okay, now the next example is question mark, or no, number 2 is how many moles of hydrogen gas, how many moles of hydrogen gas